thought would be a good topic to talk about today is these beautiful, wonderful error messages. Anyone seen one of these while you're using AWS in the past? If you haven't seen one of these yet, you will. It's like there's only two types of motorcycle riders, those that have gone down and those that will. You will definitely see one of these at some point. And this has been true for as long as I've been using AWS, and I've been using AWS since 2008, so you're going to see one of these error messages. The one thing I will say about AWS is that they're always listening. They really love feedback, they listen to their customers, and so they've given us a way to get rid of all of these error messages. You can see it right here, it's diagnosed with Amazon Q. So you can just press that button, and in fact, you don't even need this talk. I'm just going to go to the next slide. Keep going. There we go. Okay, so the standard format for an IAM error message is what principle it is that you are using is not authorized to perform, and there will be some action on some resource that you're trying to take. The resource will be completely identified here by the Amazon resource name, or ARN. And then it will give you an error message that may or may not be useful. So what's the deal with these error messages? Well, that's sort of why we're here today. The goal of this talk is to help you understand how IAM is designed, how it evaluates policies, how to write policies, as well as a couple of different techniques so that when you do get an error message and it says access denied, you'll have some techniques to help you get through those. Sound good? All right, we just had a beautiful introduction. I don't have to say too much about myself. I will say that I do run an annual survey of AWS services, and it measures the sentiment across different categories, like which services are people liking, which ones are they not liking. And so this is the third year that I've run that, and you can see the serverless framework has taken over top spot on the serverless tooling. And so it gives you a good sense for what tools to use within the ecosystem and what not to. So please go and check that out. And if you are in the area and you go up to San Francisco, there's a meetup that we run up there called the Advanced AWS Meetup. You can go and check that out. These QR codes will take you to this slide, so you can go and get these slides after the fact. All right, let's get into it. But before I do have a confession to make. This slide, this presentation was done by Bridget Johnson in reInvent in 2018. And that talk blew my mind. The way she described how IAM roles work was so good that I used that, maybe stole it, pieces of it from that presentation and updated it for how things work now, because it's been a number of years since then. I got to meet Bridget at reInvent last year, and they say never meet your heroes, but she is amazing. And so please go and watch this talk if you want to go into more details about how this stuff. But I only had a little bit of time, so I want to get right into it. IAM policies are really two different things. There's the specification, which is your responsibility for the one that is operating the cloud. And then there's the enforcement, which is AWS's responsibility. And so when you're creating these specifications, what you're really doing is writing policies. You're saying who should have access to what and under which conditions. That's your job when you're writing all of these specifications. And when you combine specifications with enforcement, what you have is access control. And access control is what this whole sort of talk is about. Like who is allowed to do what and under what conditions. The IAM policy language looks a lot like this. And internally at AWS, this is what they call the PARC model, P-A-R-C. And so you start off with a principal. That is the entity that is allowed to perform some type of action. And so this will be the Amazon resource name of the thing that is acting on some set of resources. There will be some policies where you don't need to specify who the principal is. And the reason for that will be because it is obvious. Meaning when you attach a policy to an IAM user, you don't need to specify the principal because the user is the principal. But if you're attaching a policy to like something like an S3 bucket, well, that can be used by many different principals. And so you will need to specify which principals are allowed to access that. Next up, we have the action, and that is what API call is going to be allowed. So in some cases, that will be something as simple as an S3 put operation, and you can list multiple of these together. So you don't just have just one policy per API call. You can specify multiple of these. And then resource is also a list, and so you can specify a number of different resources that the user or the principal is allowed to have access on. And in this particular example, that we've got a user who is doing a put object on an S3 bucket. And then the final part of this is the condition. And so the way to think about conditions is I want to allow these set of actions, but only under these conditions. And so there are a number of different conditions that are available. So like in this case, it's whether the person has multi-factor enabled, but it could be what tags are on the resource, what is the IP address coming from, what time of day it is. You can write conditions that are restricted to maybe 8 hours of the day where you expect these things to happen. And so all of this comes after an effect, which is either allow or deny. And the SID is just a friendly, unique name that you can give to the policy that says what it is that it's doing. Any questions so far with this? Effect is an allow or deny. Okay, so that's how you write a policy. Now, how does AWS evaluate a policy? This is the single most important thing to remember from this talk. AWS is designed to be secure by default, and so no matter what it is, the decision starts with deny. Like AWS will deny access to whatever it is that you're trying to do. If you don't remember anything else from this talk, remember the decision starts with deny. The next thing is we go and evaluate all applicable policies. Why did I put that word applicable in there? Because there can be policies at many, many different levels, at the account, at the organization, on the resource, and so there are many, many different policies that can be applied to different resources here. And what AWS does is it says, is there an explicit deny in one of those policies? If there is an explicit deny, what do you think the result is? Allow or deny? Deny, yes, exactly. That's where we stop. If there is an explicit deny, the decision is deny. If there is an allow, then what happens? Will the action be allowed or denied? It'll be allowed. Great, like everyone's happy. If there isn't an allow, what's the result? Exactly, we go back to our original decision, which was deny. And so this is an explicit deny versus a default or implicit deny. And so when you get an error message, this is really the evaluation process that it's going through, and it ended up like this is all that's happening. It's just going through this evaluation process. And so the next time you get an error message, what you're really saying is, what is not matching? That's the question that you have to ask yourself. Because you've got all of your policies and the context of the API requests that you're making on one side, and then you've got the context of all the policies that you've written. So you've got the context, the API call that's coming in, the policies that you've written. In the middle is a matching process, and that's that evaluation. And so when you get an access denied, it's because something isn't matching. So that's the question that you have to ask yourself, like, what is not matching? And that's it. That's all there really is to identity and access management within AWS. Pretty simple, except there can be policies everywhere. And this is where it makes it a little bit more complex. So let's get into a couple of these different policy types. The most common will be identity-based policies. So if you've ever written a policy that's attached to an IAM user or a group or a role, you're writing an identity policy. If you are writing a policy that maybe is attached to an S3 bucket, an SNS topic, like something like that, then that's a resource-based policy. These are the most common ones that you are going to be dealing with. If this is happening within the same AWS account, for the action to be allowed, we're doing the intersection of these, meaning that the identity-based policy could allow it, or the resource-based policy. It doesn't have to be both. So you're getting the combination, the union of both of these sets of properties. Another common one are service control policies, which are applied at the organizational level. And these have been around for a while, and if you're using AWS Control Tower, there are a whole range of different guardrails that can be applied, and those are applied through service, well, at least some of these are applied through service control policies. Resource control policies were only introduced at reInvent last year, so like December last year, so they're still relatively new, still gaining some traction. But the way these ones work is not a union operation, this is an intersection operation, meaning that both an identity-based policy and the SCP or RCP, they both have to allow it for the action to be allowed. Different way of evaluating. I find that this is an easier way of sort of trying to think about which policies apply in which different places. And so your identity and resource-based policies, they're applied at the account level. They're the ones that you're going to be using the majority of the time. And your organizational level ones are being done for service control policies and resource control policies. And while these ones grant access, these ones are used to deny access. Does that make sense to everyone? Are you sure? Because a few slides ago, I just said we start with deny. Isn't that the main thing that you have to take away? Like, we start with deny. So like, why are these doing deny? Like, how could that possibly work? If we're already starting with deny, how can there be policies that do more deny? Doesn't make any sense. The reason it makes sense is because when you go and enable service control policies within your organization, this full AWS access role gets applied everywhere, to the root, to your organizational unit, to each individual AWS account. And what this does is it says allow everything. Like, this is like an admin level role. Why does that work? Because it's just flipped the logic. So rather than writing a policy here to allow something, we've already allowed everything. So now our policies are being written at this level. This is why we can write deny policies, because that's evaluated first before we get to the allow side. And that's how SCPs and RCPs are designed. If you think about like all the RCPs have the same sort of logic, yes, they do. Oh, before I get that, here's an example of a security control policy. The effect is deny. We are, in this case, preventing modifying config rules to everything. And here's a condition. So it's saying, basically, if you're not control tower, I'm going to deny this action, meaning that only control tower is allowed to perform these types of things. Sound good? And similarly, with resource control policies, it also has a similar type of role where RCP, full AWS access, is also allowed. And so that's how it's moving the evaluation logic between these two. These are things that you need to go and enable within your account. And so if you're only using a single AWS account, you've probably never seen these before, you don't need to care about them. As you work at larger and larger organizations and companies, you'll probably already have SCPs enabled by your admin team. RCPs may not be enabled yet because they're relatively new, but like they're something that will be rolled out a little bit more and more. Okay, so we've covered two types of policies at the account level and then another two at the organizational level. I just want to mention a few more. So there are things called permission boundaries. Permission boundaries are an interesting way of ops getting out of the way of devs. So like the classic example of when you would use a permission boundary is when you, as an admin, want to give your developers access to go and create their own roles. So like, let's say they're working on a serverless application and their Lambda function needs to make API calls to other things within AWS. You want that developer to be able to create a role, but you don't want them to be able to escalate their privileges all the way up to admin level. So what you can do is you can use permission boundaries to go and limit the scope of the types of roles that they can create. And so now that frees the developer to go and work at whatever speed they're interested in because they can go and create their own roles. They just have to apply these permission boundaries. There's a bit of a learning curve to using these. If you can get over that hump, they're incredibly powerful. Scope down policies are a way of having sort of dynamic conditions within a policy to take a bigger policy and scope it down. So for an example, if you've got an application that is a multi-tenant application, so you can have multiple tenants logging into this, well, that application needs access to every single tenant's data. But when a single tenant logs in, you can scope down the policy dynamically so that only that tenant can access that tenant's data. They can't access everything else. So this is a really interesting way of using policies to sort of scope down the permissions once you've assumed that policy. When you are working with IAM roles, there are actually two policies. The permissions tab is the one that says, what is this role allowed to do? But a role can't exist or do anything until someone has assumed that role. And that's where the trust relationship comes into it. So in this case, we are allowing CloudTrail, another AWS service, to go and assume this role and then go and perform some set of actions that is defined in the permissions tab. So don't get these two policies confused because they're used for very different things. Permissions is what the role can do, whereas the trust relationship is who is allowed to assume that role. Which principles? Everything that I've been talking about so far is true within a single AWS account. But when you want to access resources in another AWS account, things change a little. When you're accessing resources across AWS accounts, both accounts need to allow this. It's sort of locked down from the outside world so that if I have an AWS account here and I have another AWS account here with a bucket that I'm trying to do something with, well, just because this policy allows it doesn't mean this other AWS account even knows about this account. So you need to create this trust hug so that both accounts are allowing the access to happen. And so in this case, you would define a identity policy for the principal that says, I'm allowed to write to this bucket, and the resource policy on the S3 bucket that says, that principal is allowed to take whatever action it is. And that's how you get to the allow. All right, who's been paying attention? We got quiz time. So, this is a single AWS account. We've got a user. They have a policy that says S3 put object. The bucket has no policy at all. And what I'm trying to do is I'm trying to copy a file or put that file into my bucket. Is this action going to be allowed or denied? Ooh, we've got some controversy here. Who's allowed? Who's denied? All right, the answer is allow. And if you remember, because this is happening within a single AWS account, it is the intersection of those two policies, the user policy or the resource policy. Which means if we flip this, the user has no permissions at all. But the bucket says, in this case, this principal is allowed to go and write to this bucket. Is this one going to be allowed or denied? Allowed, right? It's an or operation, not an and operation. What about across AWS accounts? So now we've got account A that has the principal and account B that has the resource. Denied. Everyone's getting this. All right. It's late in the day, but I feel like we're getting somewhere. And that's because this operation changed from an OR to an AND because it's going across AWS accounts. What are we doing here? Okay, and in this case, the policy is on both sides, and so it will be allowed again. All right, let's get a little more complex. Now we've got, it's cut off a little bit. Just let me. SCP is what that says on the left there. So we've got a service control policy that is only the one that is enabled by default. So when I've just turned on SCPs, it went and created this full AWS access role. So now we've got that in account A, and account A is trying to write to a bucket in account B. This doesn't have a policy, that one doesn't have a policy, but that one does. Is this going to be allowed or denied? Yes, excellent. Because it's this and this and this. And so if I go and add a policy to the bucket and that's all that I did, this will still be denied. I need to have all three for this to magically go to allow. We did it. End of the pop quiz. Congratulations, everyone. Now, even though you know all of this now, you're probably still going to get one of these error messages. So the next time you do, the first thing that I want you to do is make sure that what you think is accessing that resource is in fact the thing that is accessing that resource. I can't tell you how many times I've thought that this role that I defined is the thing that should be, getting the access denied, where it was a completely different role that ended up being used. And so you can go into the last access tab underneath a role and see when that thing was last accessed. AWS guarantees the data will appear in here within 4 hours. Whether it was allowed or denied, it'll be accessed to here. My experience tells me this happens significantly faster than 4 hours, but they're giving themselves like an SLA or something like that. So this, make sure that the role that you think is being used is in fact the one that is actually being used. And now, if you have an issue with an application, your typically first reaction is to go and look at the logs. Well, what's the logs with IAM? CloudTrail. CloudTrail are your logs. And so what you want to do is take a look at the CloudTrail event history, find the thing that is causing the issues, and inspect the details of that. And so here you can see that when I was setting up for this set of slides, I was creating a bucket policy and actually attaching that onto the resource. And so it gives you more details about what was going on. In this case, I just happened to screw up the policy, so it was a malformed policy issue. But it gives you more details about what is actually happening within that. And it also gives you more context around the API call that was being made. So if you want to get really fancy with your conditions, you can see more of the context for that API call that's coming in, and you can see which conditions, maybe it's a condition that isn't matching. Important thing about CloudTrail is that when you enable it and you create a CloudTrail, you only want to have one of these in your AWS account. As soon as you create a second one, you start getting charged a lot. The first one's free. It's another thing where the first one's free. This one is CloudTrail. The one disadvantage that this sort of has is that it won't give you data level access. So like what we were trying to do before, where it was that S3 put object, that's a data level API call. You can enable that within CloudTrail so that you can see those sorts of things. Probably not something that you want to do in your production account though, because I imagine there's a lot of data like API calls and you're going to get charged for those. So this would be one where you want to create recreate the situation that you're looking to do in like a test account, something that has pretty low volume, and that's where you would enable data logging events. Another thing that you can do when you get one of these error messages is, see how this one in particular, not all of them will look like this, but this one in particular has all of this gibberish at the bottom of it. Yep, I've only got a couple more slides. You can decode all of that with this command, and that actually gives you a bunch more information about what was going on within this. And so at the top of this, you can see allowed was false, obvious. Explicit deny, false. If that explicit deny said true, what is that going to be indicating? Well, the types of policies where we're doing explicit deny are those service control policies and the resource control policies. So probably it's going to be the cause of some of those. There is a policy simulator that a number of other talks have mentioned, and so I'll mention it here, but you can log in and go and test out your different policies. And then there's another one from the community where you can visualize your policies and understand how they're interacting within your AWS account. And so I am out of time. This is just sort of the tip of the iceberg when it comes to IAM. Please go and watch Bridget's talk if you want to get more details, particularly around permission boundaries and conditions, because she goes into a lot more details there. And I want to leave you with one final thought. This was pulled from the IAM documentation. Think about it. This is happening. This whole evaluation is happening every single time, like trillions of times a day that you make an AWS API call. There is some real engineering that has gone into making this fast, because this whole evaluation loop happens in under a millisecond. Just appreciate that. Next time you get an error message, I hope that you're just a little less frustrated and you're appreciating how much work went into this. Thank you all.